My name is Sam Diter. I'm with Epic Games, and this is creating interactive 2D fluid simulations in Unreal Engine 4. So before we jump into today's talk, I'd like to go over really quick what we're actually going to be talking about today. So today we're going to be talking about how to use blueprints and render targets together inside Unreal Engine 4 to make some really cool tools and effects. I'm going to show you 3 examples today. First example is going to show you how to take a material and draw that entire material to a render target. In the next example, we're going to create a very simple 2D painting program. And then finally, in the third example, we're going to combine all of these effects together in order to effect a fluid simulation. Now, each example that I'm going to show you today is slightly more complex than the previous example, but they all build on top of one another using blueprints and render targets. So before we jump into the first part, let me go ahead and hit Alt-P on my keyboard here so I can go ahead and play. And as you can see, as I shoot the surface, I'm kicking up some particles here, but I'm also impacting the surface with, as I would be with some type of, projectile-based weapon or something like that. If I go ahead and press 1, I'm going to kick over to the simulation here. And in this cinematic, what the cinematic is showing is it's showing some ripples. And notice that the ripples are simulating like some debris or water, some debris or something has fallen into the water and then caused the ripples to happen. Notice also that the ripples start out really strong, and then as time goes on, they start to lose a little bit of their energy, so they actually dissipate like they would in real life. So now that we've seen, a little bit about what we're going to be covering, let me talk really quick about render targets in case you don't know what they are. So a render target is just a special texture inside UE4, but the cool thing about it is it allows you to read and write data to it at runtime. So this means that you can write things like materials to a render target and then save that data off to use later in your materials. So it's a great way to optimize things inside of your materials. So now that we know a little bit about what render targets are, let's actually create a render target. So to do that, I'm going to come over here to my content browser, and I'm just going to right click, and then under materials and textures, I'm going to select a render target. I'm just going to call this RT_GDC, and then I'm going to double click on it to open it up. Now, as you can see, this opened it up in the standard Unreal texture editor that many of you might be familiar with, and also notice a lot of the same parameters that you find with regular textures are available, such as brightness adjustment. You can compress without alpha, you can change the compression settings, but the values to take note of are the size X and size Y, and this HDR. So what HDR does is it allows you to write high dynamic range values to this render target. The size X and size Y control how big or how small your render target is going to be. Other than those 2 properties right there, these work just like textures inside UE4. So, now that we've talked a little bit about what render targets are, let's jump into our first example, which is going to be a simple noise. So what we're going to do here is we're going to take a material, and we're going to take a render target, and using blueprints, we're going to draw this material to our render target. So first, let's take a look at our material noise here. So a couple things to note about this. First, there's a property I want to show you that's called Allow Negative Emissive Color. And what this does is, by default, your emissive input will cut values that are negative. So it will go from 0 to a super, super high number. What this does is it allows your negative input to read your emissive input, to read negative numbers. So you can have super high positive numbers or super high negative numbers. And you're going to want to enable this if you notice that your simulation is clipping something or you're not getting all the data that you want. And then while we don't use this setting in this particular material, we do use it in our fluid sim. So with that out of the way, let's go ahead and take a look at what this material is. So this is a simple, unlit, emissive powered material. And the reason is because render targets, in order to write data to them, you can only actually write it through the emissive channel. Trying to use base color, metallic, or roughness will result in your render target just having black data written to it, because those aren't valid inputs to write data to the render target. So what we're doing in this guy is I'm just using the noise node to generate some procedural noise, and you can find it by right-clicking and then typing the word noise, and then just clicking on it to add it to the graph. If we select the noise node and we come over here to the details panel, you can see I have a lot of different options for creating procedural noise. I can change all types of values, make it, add some black into it. When I'm done, I'm going to go ahead and press apply. And what that's going to do is you notice that my texture updated right up here, my blueprint updated, and it's updated in my material, but my render target hasn't updated. So we're going to go ahead and actually grab this blueprint and move it really quick, and that's going to update my render target. Now, before we jump into the next section, which is the blueprint, I want to explain what blueprints are in case you're not aware. Blueprints are just simply Unreal Engine's visual scripting interface. You can use it basically to put down nodes without ever having to write a single line of C++ code. So you can do extraordinarily simple things like this, draw materials to render target, or you can do a really complex thing like a fluid simulation. And all the stuff that I'm showing you today was all built in blueprints. I didn't have any programmers help me by doing any C++ programming or anything like that. All of the functionality that I'm showing you today can all be done with inside blueprints, and that's really cool. So, what are we doing inside this blueprint? Well, I have this custom event called bake, and what bake is doing is it's calling this node called draw material to render target, which will take my noise material, and it's gonna draw it to my render target. And that's it, that's all I need to do in order to get this to work. If I come and look at my construction script, you'll notice that all my construction script is doing is calling the bake function, and that's just simply so that when I move this guy, my render target is going to update. Why would I want to do that? Well, as I mentioned before, we can actually save the data from the render target to a static texture to use later on. And let's look at how we do that. So what I'm going to do is I'm going to click on my render target here, and I'm actually going to go show in folder view, and then I'm going to right click on him again, and I'm going to create a static texture. And now let me double click to open this guy up, and I'm going to turn off his alpha channel. And you can see right there what I've done is I took the data that I had inside of my render target, inside my material, I wrote it to a render target, and then I created a static texture out of it. Now, for this example, this material comes in, I think, at about 37 instructions because it's unlit, so it's very cheap. But you can still utilize this exact same workflow to optimize shaders that are 5, 6, 700, 1200 instruction counts. You can optimize that entire branch down to just one single texture, if that's what's needed, and then save all of those instructions. And that's super powerful because that means you've done this huge amount of optimization all within Unreal Engine. You didn't actually have to go outside of the engine to do something else. So, as you can see here, what they're showing in, I have them switched this time. What we're seeing over here is, right here, I just took a couple of these noise nodes and combined them with a couple lerps and some color parameters to generate what you're seeing right here. Taking this a little step further, we can see that we've generated some production-ready assets, this cracked dirt that you might see from like a dry lake bed or a dry river bed or something like that. All the textures that you see down here were all generated using this exact same method that I showed you. Taking a material, drawing it to a blueprint, and then saving out the results of that render target. And that's pretty awesome, right? All made inside UE4. Didn't have to go anywhere else, didn't have to do anything else. I could do it all within the engine. And it's super, super powerful workflow. So, now that we have talked about writing to the entire render target, what if you just want to write to a portion of the render target? That's what the next example is going to show us how to do. So, gotta stand a little further away from the speaker there. So let me not save that. So let me go ahead and click play here. And as you see, as I hold down my left mouse button, you can see I'm painting. And that's pretty cool. So what are we doing? So basically, in my last example, I had no control. I just wrote everything to the render target. Well, in this example, I'm just going to write to the portion that's right underneath my cursor. And let's take a look at how I did that by first checking out, the two materials that I used. So this material right here, all it's going to be doing is it's just going to be reading the data from the render target, okay? It's plugged into the emissive so that we can show the red channel of it, and that's it. That's all that this is going to be doing. A slightly more complex material is my brush material. So what this guy is doing is he is actually acting as my paintbrush. So each time I have my left mouse button held down, I'm going to be stamping this material down, giving the illusion that I'm actually painting. And so how does this work? Well, over here in my UV block and this brush position node, this is going to act as a placeholder so that when I go to shoot, I'm gonna convert where I'm shooting at into texture coordinates so I know exactly where to place that brush. What we're doing down here with this force side and the dividing and the multiplying is we're basically saying that when we make the brush bigger, we want to scale the brush from the center going outwards. If we don't do this, generally you're going to scale from the upper left-hand corner, and that's going to cause the brush to actually go off of, or cause the material to actually go out of the bounds, so you're not going to see this circle. You'll see like a half circle or a quarter circle, depending on how big you actually make the brush. Now the proc brush part, what this is doing is I'm just using the sphere mask to generate my brush, and the only reason I'm doing this is because I control the radius and the hardness. You could have done this with a texture, but I like doing everything inside the engine, so this is just a really quick way to make a nice procedural brush without having to worry about anything else. Finally, our brush color is just there to give it a little bit more visual oomph, paint it red or green or purple or whatever color you want to choose. So, with the materials out of the way, before we jump into the next section, I want to talk about tracing, because tracing is key to getting this entire thing to work. So, if you don't know about what tracing is, or if you do know what tracing is, I'm sorry, please bear with me for just a second. So, literally all we're doing is we're shooting rays out of our camera, right? So our camera basically acts as our eyes. When that ray comes in contact with something like this green sphere, we're gonna actually wanna place this little yellow decal right there. Okay, so we're basically gonna be shooting rays out into the world. When that ray intersects with something, we're gonna place down our material brush, okay? So now that we've talked about that, let's look at how we do that inside the blueprint. So let me go ahead and open up my Painter blueprint and kick over here to my trace from camera function. So again, just like my note says right here, we're going to literally be tracing from the center of the screen in the direction the camera is facing, okay? When that ray hits something, we want to make sure that it's actually hit an actor, so make sure it's a valid hit, and then we want to store that hit location so that we can use it over in our event graph. So over in my event graph and the apply paint with specified settings section, what we're doing here is when I hit this object, I'm going to check the size and the strength of my brush. Then what I'm going to do is I'm going to check the position. And what I'm going to do is right down here, what I'm doing is I have my mesh that's in world space, but I can't use those as texture coordinates. What I need to do is I need to convert my world space into local space so that I can then use that as the location to put the brush. And that's what this little bit of code is doing right down here. This final draw material to render target is just drawing the actual brush material to the render target, and it's just, so that displays what you're actually seeing. Let me kick this over to the other screen because the other parts are a little bit easier to explain if I actually show you what's going on. So if I click play, you notice that my canvas, everything disappears on my canvas, and if I do something like this and I hit escape and I hit play again, you notice that I start off with a fresh canvas. So what's going on here is every time I start the level, I'm just going to fill my render target with black just so I can start out fresh. This right here, this call trace from center of the screen, what this is doing is it's making sure that every time my left mouse button is held down, I apply paint. If not, I stop applying paint. And I can click it once and I will still continue to apply. I keep it held down. So this is making sure, again, we're only applying paint when and where we want to. So with that out of the way, let's go ahead and take a look at our 2D fluid simulation. And we're not going to save that guy. So if I go ahead and press play here, you notice again, as I shoot, I'm going to be affecting the water. But there's actually some other ways to affect this. So the first way I want to show you guys is I'm going to go over to this blue orb here. I need to change some stuff around, so give me just 1 second. We're going to show the mesh, and I'm actually going to click simulate, and then I'm going to pull up my render target here. So what's happening here is as this guy intersects with my render target, you can see my render target updating in real time. So what's going on? What's happening? Well, what this guy's doing is he's taking this material right here, and when this blue orb intersects with the water surface, we're going to be spawning that material that's going to then kick off the fluid sim. And this is just like my painter example, only except I'm not holding down my left mouse button to kick it off. It's being kicked off by the intersection of this into the water plane. The next example I want to share with you, let me come over here and kick this over to the rain. And we're going to go ahead and map this to the entire fluid. And let me pull up my render target really quick. Ciao. So this, what it's doing is like our first example. I'm spawning these little dots that are acting as impacts, like raindrops. And when those actually impact with the surface, we're going to be starting off the ripples. Now, again, this is just like my first example because here I don't have any control over where these are being placed. They're being placed on the entire render target. So before we jump into actually making it so that when we shoot the fluid, it'll react, there's something that I need to talk to you about, and it's called ping-ponging. Ping-ponging is just simply means that we're going to be going back and forth between two different render targets. The reason that we need to do this is because you cannot write or read data from a render target you're writing to, because you're going to be overwriting the data that you're trying to read, right? So what we need to do is in our cycle render targets function, if I zoom in here, you can see I have this RT and I have this RT2. So what's happening here is that in this render target, I'm writing whatever it is that I'm currently doing on this frame. This RT2 is containing the data that I did last frame. So then when I go to render, I'm going to combine RT with RT2 so that it makes it look like the fluid is actually moving. So with that out of the way, let's look at how we can actually make this fluid surface react to when we shoot at it. So first what I'm going to do is I'm going to open up my BP fluid start, and I'm going to come over here to my painter blueprint, and I'm going to open him up and pull him over to my other screen. So what we're going to do is we're going to take a lot of the similar functionality from our painter blueprint, we're going to put it inside our fluid blueprint so that when I shoot at it, it'll react. So first thing that we're going to need to do is create a new function called trace from camera. Then I'm going to come over to my trace from camera script to my painter blueprint. I'm going to select everything. I'm going to hit Control C. Then I'm going to hit Control V on the keyboard and paste it in. I'm going to connect my trace from camera to my line trace by channel. Then I'm going to come down here, and this is something actually pretty cool you can do with blueprints. If I right click on this, I can create a variable out of this. Now before, what you would have had to do is come here to your variables, create a new variable, figure out what type it is, give it the appropriate name, set the value. And you'll still have to set the value, but what this is doing is this is setting everything up for me. So literally all I have to do now is come here and set my interaction distance. And what the interaction distance is doing is it's saying, hey, if you're greater than 1,000 Unreal units from this actor, I don't want you to be able to interact with him. So I'm gonna go ahead and compile this guy again. We're gonna get an error, but we're gonna fix that right now. So I'm gonna come over here to my event graph and my fluid sim, and I'm gonna come to the event graph and my painter. And I'm actually going to copy this entire applies paint with specified settings. I'm going to paste them in here. Because again, we're going to want to do the same thing that we did in our 2D painter. First, I'm going to come to my brush size. I'm going to create a variable for that guy. I'm going to create a variable for my strength. And I'm going to create a variable for my paintbrush material. I'm actually going to delete these two because I need to draw to my render targets in slightly a different way. I need to invoke the drawing to them. And I'm also going to delete this entire section down here. So the reason I need to delete this section down here is because I need to do my my hit in slightly a different way. So when the simulation happens, in order to make the ripples look like they've either hit the edge and then reflected back into the simulation, we had to take the outer edges of the render target and bring them to the center, and then do the same thing with the top and the bottom. If you're familiar with making tiling textures inside Photoshop using offsetting, this is exactly what we're doing. We're literally offsetting the render target so that we're offsetting our hits so that we can account for the offset in our render target. So to do that, what we're going to do is we are going to get our actor transform. And then we are going to get the inverse and we're going to get our inverse transform location, and we're going to take the hit location, so we're going to get the inverse of our hit location. Then I need to grab my fluid size. So I'm going to get that, and I need to actually multiply this guy. Multiply him times 0.5 to scale him up, and then I need to take the return from my inverse transform, and I want to divide that by my fluid size. And what I want to do is I want to actually add one to this guy. And then I want to multiply him by 0.5. Finally, I want to connect this to the value of my brush position so that we can account for that offset. So with that out of the way, let's compile our blueprint again. And the next thing that we need to do is we need to come up here to our begin canvas to render target, and we're going to hit control and we're going to click on that one. We're going to click on our draw material, and we're going to click on our end draw canvas to render target. Basically what I'm doing is I'm setting up some batching for the render targets. Now I could daisy chain a bunch of draw material to render targets together and have that would work, but that's not the best way to interact. The best way is to interact with render targets is to do it in batches, and that's what we're going to do right now. So we're going to connect the output of our set vector parameter to our begin draw canvas to render target. And then we're going to grab the output of our cycled render targets that we're ping-ponging back and forth between. So what we've done is we have our render target. Now what I want to do is I want to inject my brush into that render target so I can affect it. And I'm going to do that by grabbing my brush material variable here and plugging it into my material. And then I'm just going to grab the output of this and plug it into the end draw. So basically, I've told it that I want to inject my brush material into my render targets, and then when it's done, I want you to kick that off to the renderer. All right, so with those two things set up, the other thing that I need to do is come over here, and I haven't actually called, so I have everything set up, but if I went to go play this, nothing would happen because I haven't actually done anything with my left mouse button. I have the code, but I have no way to call it. So let's go ahead and put that functionality in there. So I'm gonna hit Control V, and you notice I get a little conflicting node error here, and what that's basically saying is I copied in an event tick, but I already have one in here, and you can only have one event tick per blueprint, or per event graph, because event tick happens every frame. So I'm just gonna delete this guy, and I'm gonna take the output from my event tick into the branch of, into the branch node, and what this is gonna do, I need to make a variable out of this guy. So once I do that, I'm gonna come from my trace from camera output and connect it to the isSim enabled. So what's gonna happen here, I hold my left mouse button down, the simulation is gonna kick off. But if I let go of my left mouse button, the simulation is gonna stop, and that's not how fluids actually work. They will continue to move even after you've shot at them. So we're gonna take the false, and we're actually gonna also connect it into the isSim enabled. So hold down my left mouse button, I'll affect the fluid simulation, I'll let my left mouse button go, and the fluid simulation will still continue to run. So, excuse me, once I have that set up, I need to come over here to my construction script, and right down here at the end, I need to create a dynamic material instance. I'll plug the output of that into there. And then I need to grab my material brush, and I'm gonna go ahead and put it in there. And now what I'm gonna do is I'm gonna assign my paintbrush material, oops, and I'm gonna set it. So what I've done now is I've allowed my create dynamic material instance, this create dynamic material instance, I fed it with my material brush. And now I've set it to a variable so that when I come over here to my event graph and I wanna come here and I wanna change the brush size or the brush strength, which I should probably actually fill in with some variables right now, or we won't actually affect the surface. This is allowing me to actually affect those guys. So let me compile that, and we're gonna full screen that guy over there. I'm gonna find him in the content browser, drag him into the world, pull him up, and let's go ahead and enable this, and let's press play. And there we go, I'm affecting the fluid. Look at that, that's pretty sweet. And then if I kick over here to F1, you can see, not only am I messing with I'm displacing the surface two ways, I'm displacing the actual mesh itself, and then if I kick over here into lighting mode, you can see I'm actually displacing the normal map as well. And which is pretty sweet. So, let me close this guy. And so some tips, tricks, and more info. So basically, in our fluid sim, we do have the allow a negative emissive because we want the waves to go up and down, okay? And if I don't have that enabled, what's gonna happen here is I'm gonna literally cut all that data off. I'm not gonna have that data anymore. Enabling that again is gonna allow my sine wave to have both positive and negative values. So if you're using this and you're like, I'm not seeing my blacks or I'm not seeing my negative data, enable that and that will help you see that type of data. Remember again, you can only use the emissive input when rendering up material to a render target. You can use the world position offset. That's the only other one that you can use. If you try to use any of the other inputs, you're just gonna get black written to your render target. All three of these examples can be downloaded from the Unreal Engine launcher content examples. You'll get the Baker, you'll get a different version of the Painter. The Painter is exactly the same, it's just that painter happens to raise up the height of the surface that you're painting on. You can just disconnect that in the material to get the same functionality. And finally, you can check out all of our documentation on blueprints and render targets at the following link. So that's all that I have for you guys today. If you have any questions, please, I'll be over here on the side. And I want to thank everybody for coming and enjoy the rest of your GDC.